some estimations. From these estimation only we can think about the duration before the starting and the project delivery in time period and everything, right? Then common challenges of the estimation. First thing is unclear requirements. Unclear requirements mean sometimes if the customer is not familiar with the uh, systems, they may introduce requirements time to time, and some requirements are not clear for the developers or the development team, right? So this is one of the major challenge of estimation of project. Then technological changes. This mean during the sometimes during the development, some technology may change. So sometimes we need to reorganize everything that we have completed before the technology changes, right? Then human factors mean sometimes developers may resign from the company or the development team. Then they have to think about other developers, and then the new developers may not have some I mean the experience like the previous one. So like that, sometimes human factors also affect for these estimations. Lack of historical data. Lack of historical data, if it mainly for the startup companies, because if we are going to start a new company startup, then we don't have any historical information about project implementation. So in that case we cannot estimate the accurate estimations. We cannot have any accurate estimations because we are new to the industry. Even though the functionalities is clear, we may think at the initial level it may take 1 month, but in the development it may take 2 or 2.5 months. So these are for things, lack of historical data. Then scope creep in the scope of the project, right? These are the most common challenges related to the estimation, right? Now, for the estimation, actually we have to estimate time and the effort. Mainly we are think about the time and the effort. To do that, we use the commonly we use what a model called COCOMO, right? COCOMO. Actually, COCOMO means constructive cost modeling, right? COCOMO stands for constructive cost model. It's a software cost estimation model used to estimate development effort, project cost, development time, team size, so on, right? This model was developed in 1981. Actually, COCOMO helps project managers to answer questions such as how many people are needed, project that means team size, how long it will take the project, development time, what is the approximate cost, project cost, right? These things we can identify using this COCOMO model. In COCOMO model, actually we have in the model itself, it has several lot of constants and values. From this value, we have to think about our project based on these values, right? Let's discuss about COCOMO today, right? So COCOMO, constructive cost modeling, actually mainly used for software project planning, budget estimation, resource allocation, schedule estimation, risk management, the things that we have discussed here also. Project cost, development time, same thing here. Budget estimation, resource allocation, schedule estimation, risk management. There are two main major versions in COCOMO. COCOMO 81, that's mean the 1981 introduced the COCOMO model. So that model we call as COCOMO 81. Then COCOMO 2, it's the actual COCOMO 81 is the original model. COCOMO 2 is the modern update version. We will discuss only COCOMO 81 model, right? Actually, in COCOMO 2, actually we have only few differences, actually fine-tune the COCOMO 81 model. In COCOMO estimation, uh, actually we have to think about our project. In the COCOMO, all the projects divided into three main categories based on the features of the product or the project, right? First one is organic projects, right? Organic projects mean small and simple projects. Small and simple projects with small development teams, right? Experienced developers, flexible requirements. These are the main characteristics of organic projects, right? So, examples, payroll systems. Because payroll system, if you think about a payroll system, it's a simple one, and we know what we have to do in payroll system. Library management system, student information system. These are actually small projects compared to other real world projects, right? So by using small development teams, we can complete these things, right? If we have experienced developers, then it is very easy, right? And if we think about features, familiar technologies we can use, minimal constraint, less complexity. All right. Now, library management system, we all know what is a library. We have to register books, register users, borrow books, handling stocks, like that. The complexity is minimum, less complexity. Constraints are minimal constraints. And also we can use whatever the familiar technology that the development like, right? Simply, organic projects are small and simple projects. By looking at the example, you can understand what are the projects that we can consider as organic projects in our real world, like payroll system, library management, student management, stock management, post system, these type of things, right? Then, second category actually, semi-detached projects. Semi-detached projects mean with medium complexity, with development team also medium size, mixed experience levels. Give me 1 second. Okay, semi-detached projects with medium complexity, with medium size of teams. Development teams are small, medium size. Mixed experience level, that's mean we may have highly experienced developers and low experienced developers, right? Uh, Project sample, database systems, compiler projects, medium business system with moderate constraint and moderate complexity. So actually, by looking at the thing, it's somewhat difficult to identify whether a project fall into this category or organic category. But sometimes but next one must be, you can understand, next one must be the highest complexity one. So between these two, smaller and organic and highest, that's mean embedded projects, last one, in between that one, you can think about this is a semi-detached projects. Okay. So next one is embedded projects, highly complex systems, strong hardware and software interaction we need in this type of systems. Strict regulations also apply for this one. For an example, air traffic system, medical equipment software, banking real-time system. Now you can, by looking at the projects, you can think about what is the idea of embedded projects. You know that air traffic systems, if we it is very highly complex system, and real-time constraint we have, and also high reliable requirements also there, because if we miss something, if we make a small mistake, it will damage a lot air traffic system. The medical equipment software is also same thing. Ne? If we if we have any small bug, or if we miss any small requirement, it will lead to total fail of the system. Bank in real-time systems, these are the embedded projects, right? So features are real-time constraints. We have to consider lot of real-time constraints, high reliability requirements, and complex interfaces. Interfaces also complex. So these are the main three categories that we are looking at in COCOMO model. What is organic projects, small projects, simple projects, semi-detached projects, medium complexity with medium team size, and embedded projects, highly complex systems, strong and hardware interaction also in there, restrict regulations like air traffic control system, online banking systems, right? Because after identifying the project category, we have to apply different kind of constant in the calculations. That is the thing, right? So let's think about COCOMO model. Actually, COCOMO model again, COCOMO 81 again divide into three categories: basic COCOMO model, intermediate COCOMO model, and detailed or embedded COCOMO model. Right? First, we will go through the very basic COCOMO model, then move on to the other models. Okay. So basic COCOMO model, that is the simplest estimation model. It estimates efforts based only on project size, that is LOC, line of codes. KLOC means kilo line of codes. No other factors are considered. So in the basic COCOMO model, only kilo line of codes. Project size is the main factor that we are looking at in basic COCOMO model. By using that, we have to think about the estimations. So there are two estimations in COCOMO model. First one is effort estimation. Effort estimation, the equation is effort equal A into kilo line of code to the power B, right? So effort result is actually returns person months in person months. KLOC 1000 lines of codes, kilo lines of code. A and B are constant based on the project type. Now we discuss there are three project types available for the COCOMO: organic, semi-detached, detail. Based on these, the AB values, the values for the A and B constant change based on the project type, right? And after calculation of the effort, we can have another formula called development time formula, time development, that is C into effort, C multiplied by effort into the power D. Again, C and D are constant. The result is returns time in months, right? Only two equations. First one, effort estimation. Second one, time in estimation. Effort estimation is A multiplied by kiloline of codes into B. A and B are constant. Then time development, total time development is equal to C multiplied by effort into the power D. A, B, C, D are constant. A, B, C, D are constant. These are the constant that we have to use, the values. Project type A, B, project type organic. Then if it is organic, we have to use A as 2.4, B as 1.05, C as 2.5, D as 3.8. Then semi-detached projects 3.0, 1.12, 2.5, 0.35. If it is embedded detailed one, project, highly complex one, then we have to put A as 3.6, B as 1.2, C as 2.5, D as 0.32. So by using A, B, C, D values, we can calculate effort and the time for the development. Right? Now, for a small example, suppose we have 50 kilo lines of code and organic project. So organic, if it is organic project, we have to go to the table. We have to use A as 2.4, B as 1.05. By using that, we can have 2.4 into 50 into 1.05 to the power. Right? So effort is 146 person month. So by looking at this, you can understand for this what you call course module at the final exam, you need scientific calculator to calculate these things. I will show you today last year exam question also based on this COCOMO, right? So you need to have calculators. You need to use calculators in the exam. So effort is roughly 146 person month. Now we know what is the effort. Then we have to think about the time. That's mean development time estimation. So development time estimation is, what is that? 2.5 into 146 effort that we have in the previous equation. Actually, this line must be go to this one. 0.38, because we know that here 2.5, 0.38, D is 3.38. By using these values to this formula, now effort we know 146, C is 2.5, D is 0.38. By using that, we can have calculate development time is 16.6 months, right? 16.6 months. Now we know total effort that we have to use, that is 146 person month, and time 16.6. So by dividing effort, the value by using TD, total time, we can have the team size. So team size is effort divided by time. Effort is in months, person month, 146. And this is then total time 16.6. So divide 146 by 16.6, roughly that is 9. So we need the team size of my development is 9, right? So by using the COCOMO model, basic COCOMO model, we can understand, we can get values for effort, total time, and team size. Team size is effort divided by time. Because effort is in person month, here month, person month divided by month, that means month, the number of persons, right? So this is basic COCOMO model. Only ABCD value constant we have to consider, and for the considering the finding the ABCD constant, we have to use this table. For using this table, we have to identify what is the type of our project, whether it is a organic project, semi-detached or embedded. Now here actually in the example, it's clearly mentioned that this is an organic project. So we have to use the constant related to the organic. That's all. So that is the basic COCOMO model, right? Then let's move on to the intermediate COCOMO model. In intermediate COCOMO model, we have only the adjustment for the effort, right? In here, we are thinking about cost drivers, right? Project attributes, hardware constraints, personal capabilities. By using these things, we can have more accurate estimation for the effort, right? Now we have EFA, effort adjustment factor. We have to use A into kiloline of codes to the power B and multiply by that thing by using EAF value, effort adjustment value. For the intermediate COCOMO model, actually we have several values, different values for AB constant, right? Then we have to think about what is this effort adjustment factor. Effort adjustment factor is uh, actually we have to calculate that thing using cost drivers. Intermediate COCOMO uses 15 cost drivers grouped into 4 categories. I will show you. So actually EAF value is product of all cost drivers, driver multipliers, right? For the moment, just think about it is the multiplication of all the cost drivers. Now here we have 15 cost drivers. According to the project, we may have think about sometimes 5 or 6 cost drivers. So we have to multiply these all cost drivers to get the EAF value. That's all, right? These cost drivers actually divide into several categories like project attributes, required software reliability, database size, product complexity, these are the product attributes. Then we may have hardware attributes, runtime performance constraints, memory constraint, machine volatility, like that. Then personal attributes, analysis capability, programmer capability, application experience, right? Then project attributes like software tools, development schedule, modern programming practices. These are the things, the categories of cost drivers. You don't need to think about these things because in the table we have several different values for these things. But the only thing is, for the intermediate COCOMO model, we have different values different to the basic COCOMO model for the constant AB constants only. So AB constants we have separate COCOMO table. Value table. For organic one, 3.2, A is 3.2, 1.05. Now, if we consider about this one, you can see 2.4, 1.05. But here, 3.2, 1.05. Then semi-detached 3.0, A, B is 1.12. Now, in the basic COCOMO model, it is 3.0, 1.12 same. Embedded 2.8, 1.12, here 3.6, 1.12. The A values are changing for organic and embedded system, embedded projects in intermediate COCOMO model. Right? That's the only thing. Right? We have to use these AB values in the intermediate COCOMO constants, as intermediate COCOMO constants, A and B. Now, for an example, if you think about a project, simple project like a KLOC 40, organic project, EFA value 1.15. So, just this is as this is organic project, we have to put 3.2 and 1.105 as A and B. So, we can just put here and multiply by 1.15. So, effort is roughly here 175 person months. Right? Now, by calculating here, actually, if you get 174.35 like that thing, we have to calculate that thing as 1.75. The higher value, okay? Effort, always the decimal points. Now, if I calculate this one, I don't have, let me test, check with my phone whether I can convert this into scientific. Oh, I don't. Scientific we can have. That is 3.2. No, first we have to think about 40 into 1.05 into 3.4, 3.2 into 1.15. So, actually that is 177 or something. So, I don't know why this thing. Anyway, like that, you have to take the whole number because that is months, right? Roughly whatever the value that we have here, we don't need to think about that. We have to calculate this thing. Then, so EF values and then it's over. Then what about find the development time? For development time, we have to use same values here. Basic COCOMO model because A and B values are changing, but C and D values for CD constant we can use same. We have to use same values 2.5, 0.38 values to calculate development time in the COCOMO what you call intermediate COCOMO model also, right? So that's the formula. So then we have to think about the importance of the cost drivers. Cost drivers improve the estimation accuracy because they consider reliability requirements, project complexity, team capability, performance constraint, development practices. By looking at these things, you can understand how important these things for the given project. Reliability requirements. How reliable think if it is a online aircraft system, then that must be very high reliable system. Project complexity then again much bigger than normal organic ones. Then team capability must be handled. Performance constraints must be there, different from organic to semi-detached and embedded system. The development practices that they have. So without cost drivers, estimation may become unrealistic. So we have to think about these intermediate or the cost drivers. So in the COCOMO model, intermediate COCOMO model, we have a table like this. There are 15 cost drivers, product attributes, categories into product attributes, hardware attributes, personal attributes, project attributes, and under the project attributes we have required for software reliability, size of the application database, complexity of the project, and then very low, these are the value. Very low it is 0.75, low 0.88. Likewise, some values are not available, but this is the table that we have to use. You don't need to remember all these things because normally in the paper for the past years also, if you look at the past papers, all these tables, that mean this intermediate constant table, basic COCOMO constant table, and cost drivers table are given in the paper because these are standard. So by looking at this one, you have to calculate the whatever the effort, right? Right. Let's go to a simple example. A software plans to develop online banking management system. Estimated project size is kilo lines of code 50. Semi-detached, right? Now medium complexity, mixed experience development time, moderate system constraint. We have to look at these are the cost drivers. For an example, cost drivers, there are 1, 2, 3, 4, 5, 6 cost drivers. Required software reliability very high. So very high mean very high, sorry, it is high. So it is 1.15, right? Database size, again high, database size, data. The value we have to take 1.08. Product complexity high, 1.15, right? Then analyze capability high in the table. So analyze capability, that is personal attribute, analyze capability high 0.86, right? Then software engineering methods that we are going to use very high, in the rating is high. So software engineering capability 0.86 again. Sorry, engineering methods, methods mean 0 point here, experience 91. Then software tools, again at the bottom we have software tools 0.91. So these are the values that we have to use according to the description, right? This is the cost drivers that we are going to consider for this intermediate COCOMO table. Now, to calculate the EAF value, adjusted effort assessment factor, we have to multiply all these things, 1.15 into 1.08 into 1.15 into 0.86 into 1.91, 1.91, right? Like this. So adjusted estimation factor is 1.02, right? So as it is a semi-detached project, we have to use AB values. So AB values in the intermediate COCOMO table 3.0 and 1.12. So we can put these values here as for A and B. Now we have calculated EAF value. We know how kilo line of code 50. So by putting A 3.0, KLOC 50, B is 1.12, EAF value 1.02, then we can think about the effort calculation. Effort calculation is 3.0 into 50 into 1.12 into 1.10. 50 into 1 to the power 1.12 is 79.97. So effort is 244.7 person month. Right? Now we have calculated adjusted effort by using this adjusted uh, factor, effort adjusted factor 1.12. Now after calculation of the effort, now we can simply put a CD constant to calculate the development time. CD constants from basic COCOMO table, right here. Basic COCOMO table, this is semi-detached 2.5 and 0.35. So just put that value to this calculation 2.5, 0.35, and that is 17.1 months roughly. Now to calculate the team size, just divide this 444, 244.7 into 17.1 by 17.1. That means we need 14 developers. Right? 14 developers. So these are the calculation, estimations. By end of the calculation, we can put some summary like this. Projectized semi-detached, line of codes 50, effect factor effect adjusted factor 1.02. So effort 244.7 person months, development time 17.1 months, team size 14. 14 developers, right? Now, if we think about this uh, effort adjusted factor, right? Now, it says 1.02. That means more than 1. More than 1 means we have to put additional effort. If we think about this is as a percentage, 2% additional effort to this one. As this is high reliable, very large database, product complexity is very much high. So that is why we have to put additional effort. Now, if we have AF value something like 0.95, that means it is less than 100%. Not a big, I mean not a complex project. Now, if we have 1.35 or 1.57 like that value here, that means it's a very difficult one. We have to put additional effort to the project, right? To the project, right? Now, if we go to this project, this one, now you can see these values are, some values are less than 1 and some values are greater than 1. Now, think, for an example, this one, use of tools. Use of tools in the very low value is, if it is use less tools, 1.14. So effort is more than 100%. But if we use more tools, the factor the constant is 0.83. That means if we use more tools, the effort is less. Understand? Now looking at these values, use of software tools, if we use less tools, we have to put manual effort more. You can understand. For an example, testing. If we use manual testing, we have to put more effort. But if we have tools to test, then our effort is less than 100% compared to manual testing. It is 0.83, right? Now again here, software engineer capabilities, that means experience of the software engineers, if it is very low, we have 1.42. Actually, nearly 40% additional effort. But if we have experienced ones, very high, it is 30% less than the original effort. It is 0.70. Likewise. Right? Likewise. Now, in product attributes, if it is getting larger, I mean the low to extra high, the values are changing plus. I mean the effort increase gradually. 0.75, 0.88, 1.0, 1.15, 1.40. But personal attributes, it's reducing the effort. Project attributes, again, reducing the effort. Right? Application of software engineering method, if it is low, we have to put more effort. But if it is very high, we have to put less effort. That is why we have 0.82. So based on that, they have developed this cost driver intermediate COCOMO table values. Right? We can simply understand by looking at this table how it's changing to low to high, very low to extra high. Some factors are increasing, some values are increasing, some values are reducing. That must be there, right? Programming language experience 1.15 if it is low, but if it is high, 0.95 compared to less effort, to very low to high. So these are the things available in this cost driver table. Actually, the interpretation of the values. Or if we want to explain the values in words, that is the thing. So you have to understand these things, okay? Not just put in the values and find in the answers and everything, but you have to analyze the project or describe the project according to the values that we are using, right? According to the values that we are using. Okay, then final one. We can finish the lecture very quickly. Ne? Okay, final one, detailed or advanced COCOMO model. Actually here, detailed COCOMO model, most advanced version in COCOMO 81. It includes all the intermediate COCOMO features, that means that cost drivers. And additionally, we have phase-wise effort estimation. Phase-wise effort estimation means we can divide one project into different phases. Analyze phase, I mean the project development phase, coding phase, testing phase, then deployment phase, likewise. We can divide a project into different phases. Now, by using detailed COCOMO model, we can think about effort for different phases in the project. Actually, this one is used very large project, complex system, detailed planning for. If we need these things, we have to use detailed COCOMO model, right? If we think about phases, actually it's separate different phases like this. Requirement analysis. This is the initial phase. We know that for the project, we have to first think about the requirement analysis. So one phase. So in detailed COCOMO model, we can estimate how much effort we have to put for the requirement analysis. Then we have to design the system. Then coding, then testing and maintenance. These are the 5 phases that is available in the COCOMO advanced model. Requirement analysis, system design, coding, testing and maintenance. Right? Now you can think, uh, okay, let's think about the working practice. Okay, working principle is something like this. First we have to think about the cost drivers, and like previous example, we have to estimate the effort by using cost drivers, by using intermediate COCOMO model. Then effort we have to distribute it among the phases like this table. This is effort distribution table. Effort distribution table. Right? Now, as I mentioned you in the previous slide, we have different phases here. Different phases here. Like plan and requirement analysis, plan and requirement analysis, then system designing, detail designing, code and testing, integration test. Code and test, integration test. That means these are the things, right? Now, if it is organic one, S less than 2, I will explain what is S. Actually, S is kilo line of codes, right? S less than 2 means less than 2 kilo line of codes. That means very small project. If it is 32, less than 12, medium project. If it is 180, large project, 320 kilo line of codes, extra large project, right? Likewise, here we have effort distribution table. Effort distribution table, small, medium, semi-detached medium, semi-detached large, embedded extra large. So these are the effort distribution table, right? Effort distribution table. Now, actually, wait. Right? Now, if we think about the meaning of this table is, if we think about organic small project less than 2K, right? From the intermediate cost table, intermediate COCOMO table, we can calculate the total effort by using cost drivers. From that effort, total effort, 6% of 6% of effort we have to put for the planning and requirement. For designing, 16%. For detailed designing, 26%. Code and testing, 42%. Integration testing, 1.16. But this is standard table, but the total of this one is 106, 1.06. I don't know why that thing. It's something like that, right? Now you can see small, if the the project is very small, we have to put more effort for the code and testing, but less effort for the planning, right? Because the requirement is very much understand. But if you think about larger project, planning and requirement analysis is 88%, system designing 18%, detail designing 25% of effort. If we have much in here, actually the testing, the code and test, actually we have to have only 26% of the total effort, but for the integration we have to put, as this is very large one, we have to integrate everything together. In that way we have to put 31% of our total effort for the integration, right? So by looking at this one, right, you can see now here semi-detached large one also, it's increase in the value of integration testing. As the project is getting larger and larger, integration testing getting larger and larger, and code and testing getting lower and lower, right? Okay, give me 1 second. Give me 5 minutes, okay?
Recording stopped.
Okay, right. Wait. Recording.
Recording in progress.
Right. So by looking at the effort distribution table, we can think about how it's changed. Right. So if we think about these phases, right? uh, these are the meaning of these tables. I mean the columns. Model and cost size. That's mean the first column. It depend on the project category and the size. Planning and requirement analysis. Requirement gathering and planning effort. System design in column, that is a high level system architecture design. Detail design mean model level detail design. That is why we have large effort compared to increasing the effort by cost and model, right? Then coding and testing, that understand coding and unit testing. Then system integration and final testing, integration testing. So these are the columns related to effort test distribution table, right? So we have these six columns. Accordingly, we have values, percentages. How our total effort uh, divide into different phases. So after calculating the effort by using intermediate COCOMO table, we can, if we need system designing effort, we can use this value and get the percentage, right? So that is the idea of this, what you call as effort distribution table. And same wise, S is actually kilo line of codes, right? Here we have S is a kilo line of codes. We can divide the model and size based on that thing. Organic is small, organic medium, semi-detached medium, semi-detached large, large, embedded extra large, right? So same way, sorry, this must be not effort distribution. This is uh, effort distribution. Then this is time distribution table. We know that by using the intermediate COCOMO table, we can think about the total time, and the time can divide or distribute according to these values in this advanced COCOMO model, right? Now, for an example, if a project 10 months project, semi organic small project, total duration 10 months. So 10 months means 1 month for the planning and requirement analysis. For coding, 3.9 months. Integration, 1.8 months. Likewise. After calculation of the total time for the model, the project by using intermediate COCOMO table, right? Then we can distribute that time according to these values. That is the idea, right? So by using advanced COCOMO model, actually we can think about, we can plan our project more precisely, pace by pace, effort and the time, time here, effort distribution, this is time distribution, different values. These are standard, right? So the trends in the table, right? Trends in the table, larger projects need more testing. As project increase, integration testing percentage increase. We saw that here. As the project is getting larger and larger, integration testing effort getting larger values, larger percentage, and also time also getting larger, right? Because of it has, if it is a large one, more modules, we can divide that total project into several modules, large modules, more modules. So to integration of these modules, we need to have more effect and more time, right? Higher defect probability also there. Ne? Then embedded system require more planning. Now here again we can see that even in the time distribution table, we have to put more time for the larger systems, right? So design and testing, reason is strict constraint, safety requirements, hardware dependencies. These are some reasons for this time, increasing the time, right? And coding percentage reduce in the large system. Small systems spend large effort on coding, but large system spend smaller amount of compared to the small projects. Coding phase is, the percentage is low because we have already put more effort in coordination, testing, designing and testing, right? So that is why we need this advanced COCOMO model. So detailed COCOMO models helps project managers, team leaders, software architects to allocate staff properly. Phase by phase we can allocate staff. Estimation of the schedule, phase by phase. Monitor the project progress, then we can think about the progress phase by phase again. Reduce the risk. Reduce the risk means as it is divided into phase by phase, we can reduce the risk of the project, total project. So this is all about advanced COCOMO model, right? Okay. Wait, let me show you one. Screen. Yes, this one. So this is the past paper. I think this is last year or year before last. First question related to some explore why real world measurements may be insufficient for software metrics. That is a essay type 1. Then consider the software size. Lines of code can be mislead. Critically analyze this statement, highlight the limitation of LOC as measurement of size, particularly give practical examples, right? Then third question, actually it is GQM. We have discussed what is GQM, goal question metric, approach about that. Then if we go to the last question, here you can see the government of Estonia hope to change their existing stock market system and wants to get an estimate about the effort required and duration. The project involves the development of real-time stock market system that will be run on the high-end Linux server with minimal latency, right? These description actually to understand about the cost drivers, okay? The backend of the system requires communication with banks, stockholders and Central Bank of Estonia. All data should be encrypted and needs to implement in a high level of cybersecurity. According to the expert judgment, the code base will be as follows. Total cost base 500 kiloline of codes. Out of that 150 comments, 30 unit test cases. Management decide to effort lines of code to estimate and also consider decide to take effective line of code. Effective line of codes mean we have to remove these comments and unit test cases from the total code base. 500 minus 150 and 830. That is the code base that we have to use for the calculations. right? Consider the following cost factors. Reliability must be very high with zero downtime. Size of the database should be high according to external data and internal data. Need very high level, same kind of application experience programmers with at least 3 years of experience in Python and mid-level modern programming practices. The project should be conducted within high modern programming practices. Runtime performance constraints should be very high. These are actually again for the understand or the determine the cost drivers. Then the question is estimate effort, duration, number of developers required for the following phases: designing phase, code and testing. Your answer should be include very well-reasoned discussion on the section of parameters and cost drivers along with the justification choosing the particular level of each. So based on the understanding, you have to put your justifications, right? So in the table paper itself, we have provided basic COCOMO table, intermediate COCOMO table, cost drivers table, right? And detailed COCOMO table. So you don't need to memorize or write down anything of this table because these are standard value. Now in the answer, we have to think about in this way. Okay, let me get one. Okay, these are the features: high security, stock market, minimal latency, real-time banking integration, high reliability, encryption and cybersecurity, right? Then selected type embedded because it is not organic one and not detached one, semi-detached. This is an embedded system, highly detailed one. Reason, so you have to select this one and you have to put the reasons, justification that we have, why you have selected embedded. So you have to write down it's a real-time processing, high reliability, strong for performance constraint, critical financial transactions, cybersecurity requirements. Then we have to calculate first thing is the effective code LOC value, that is 500 minus 150 plus minus 30, that is this is for the comments, this is for the test cases. We have to deduct these things and get the final value for KLOC, right? So selection of COCOMO model, cost drivers are provided in the statement, so we have to use intermediate one, and we need to answer phase by phase. We need to think about the cost, wait for the, we have to think about design and the code testing, effort, duration and number of employers. So to do that, we have to go to detailed COCOMO model for that thing. So intermediate plus detailed COCOMO value. So parameters from the intermediate table, 2.8 and 1.2 is going to use as A and B. Then cost drivers, right? These are the cost drivers. Now we have to choose these values from the cost drivers table based on the justifications. Required software reliability very high, that is 1.4 according to the table, because it says zero downtime and zero downtime financial system. Database size very high because large transaction and market database. In the description, it clearly mentioned here. Database size should be very high according to external and internal data. So we have to put this justification for this by why we have select very high level of database size. Then product complexity very high again. Then the multipliers are actually coming from the table, and this is the justification. Then hardware attributes, cost drivers, runtime performance of the constraint very high, so multiply 1.3 because minimal latency required in the system description. Then memory constraint high, large real-time data is processing in the system, so that is why we have to think about memory constraint as very high. Then virtual machine volatility, nominal, that is stable Linux environment. It says it's use Linux environment. Then the required turn down time, high, fast response requires. Likewise, we have to choose the cost drivers according to the description. Then after choosing the cost drivers, we have to calculate EAF value based on these cost drivers. Multiplication of all these things, that is 1.69. Now we know what is EAF value, then we can put that value to the intermediate COCOMO formula, effort equal A into A multiplied by kiloline of code into the power B into multiplied by EAF. So this is the formula. So calculation, after calculation it says 4,793 person months we need to, this is the effort that we have to put for our project. Then we have to think about the time. So time is CD values. These CD values we can get from the basic COCOMO table, and applying these values for the effort that we have calculated, we have here 37.7 months. So team size, just divide effort by total time, that is 127 developers we need for the total project. For the total project, effort 4,793 person months, then total time 37.7 months, team size approximately 127 developers. Then we have to go to detailed COCOMO table for the phase distribution. Since this is the embedded project, large, extra large one, because SC is greater than 232, so we have to use embedded extra large table, right? Embedded extra large mean the final row, right? This is embedded extra large values for the effort estimation. This is effort distribution, then this is time distribution. Now we know the total. By using these values from the detailed COCOMO table, we can simply calculate the designing phase, because in our question it asks the values for the designing phase. So designing phase, designing phase, effort is 0.18, time schedule is percentage is 0.38. Then we can simply multiply this total effort into 0.18. So for the designing phase we need 683 person months, and the duration 14.3 months, and the developers we need for the designing 60 developers. Effort divided by months for the designing phase. So we need 60 developers. As a summary, we can say effort 863 person months, duration 40.3 months, developers required, duration 14.3 months, developers required 60 developers for the designing phase. Then same as designing phase, we can think about code and testing phase. The values that we can get, that is 0.24 and 1.6. So that is actually from the COCOMO table, detailed COCOMO table here. Now we have to think about coding and testing. For the effort, 0.25 here, and for the time 0.16, this one. So by using these two values, these two percentages, these two values, we can calculate the effort for this code and testing phase. So code and testing phase total effort is 4,793. From that we have to put 0.25 for the code and testing. That is 1,150 per month, right? Then the code and testing duration, that is total is 37.7. From that we have to put 0.16%, 16 to the duration, that is 6 months. So developers that we need for the code and testing, that is 1,150 divided by 6. That means 192 developers we need for code and testing, right? So this is the answer. So this is some justifications. Why embedded model was selected? System is real time, high reliability, has strict runtime constraint, requires encryption and security, interface with external and financial system. Therefore, embedded COCOMO is most appropriate. Likewise, you have to put the justification. Why personal multipliers reduce effort? So these are some outcomes from this table. So this is what you have to do when we have if you have a calculation in COCOMO model, right? You can check these things in the past papers also, right? Last question is normally used in the COCOMO table. Others are from other things that we have discussed into different categories, quality, size, QGM, lot of things that we have discussed. Ne? So that's about how we can uh, complete the actually the estimation process of a project using COCOMO model, right? So I think it's very easy because you have to put good justifications for the selections. That's all. So actually in this course module, most of the things that is available in the syllabus is over. So, but I need to discuss some special points related to software metrics and measurement under this course module. So I will have another 1 or 2 lectures, then we can actually finish the course module, all the contents, right? So now if you check your past papers, you must be able to answer all the questions in the past papers. Sometimes the method that I have used to discuss this course module is somewhat different from the previous lecture, because previously this was done by visiting lecturer Rangana Samarasinghe. So actually he is when I am discussing with the course module with him, he said that this is the most valuable part in the software industry, because he is a CEO of one company. So he said that this course module actually not available for most of the courses, but this is much more valuable than because it is totally depend on the managerial decisions, not just like development like that thing. So that is why he said that this is more important for the future of your undergraduates. That is what he said to me, because you can join like a software engineer for a company, but when we are getting experience and getting promotions, you have to climb up the ladder, architects and like that. In that level, you need to use these techniques, right? As a developer, sometimes you don't need to know about COCOMO because you have to, the managers and the senior people will assign you some project and you have to complete that thing within given time of period. But how they do allocating that thing? These managerial decisions actually made by these measurements, metrics and measurements, right? So that's all for today. Actually, I will upload the COCOMO model also for the CAL today. Then and also the video, as usually I use in the previous one also, I will share the link. I will upload this one to OneDrive and I will share the link. Okay. Now, anything special things that you have discussed in the future? You can tell me any idea about this under this software metrics and measurement course module. If you have any suggestions, I can complete that thing. Anything? Okay, if it is not, shall we wind up? Then if we need to have any lectures, actually I have a plan to have another 1 or 2 lectures. I will let you know whether we are going to continue the lecture next week or not. Right? Right. Okay. Then let's wind up the session.
Recording stopped.